Okay, let's talk about the biggest story ever told. Seriously, we're going to go on a journey that spans 13.8 billion years, all the way from the first tiny spark of existence to, well, to right now. This is the story of everything, which means, yeah, it's our story too.
It's really the ultimate question, right? If you want to figure out our place in this huge cosmos, you've got to go back. And I mean way, way back. Before Earth, before the sun, all the way to the very first moment of time and space itself. So here's our starting line, 13.8 billion years ago. I want you to try and picture this. The entire universe, everything you see, everything you are, all of space, all of time. It was all crammed into a single point, hotter and denser than you can possibly imagine. And then, bam, it all burst out in the event we call the Big Bang, and the cosmic clock started ticking.
All right, so let's start right there, at that first moment. How do we get from a bang to stardust? How does a flash of pure energy become a universe filled with countless glowing stars? This is the part of the story where the universe finally turns on the lights.
The first second was just chaos, a super hot, dense soup of tiny particles. But just 3 minutes later, things had cooled down enough for the very first elements to form, mostly hydrogen and helium. For the next 380,000 years, the whole universe was like a thick, glowing fog. But then it finally cleared, and light could travel freely for the first time. The stage was set, and after 200 million years of darkness, the first stars finally flickered on, ending what we call the cosmic dark ages. And here's the most incredible part. We can still see the leftover heat from that initial fireball. It's called the cosmic microwave background. You can think of it like a baby picture of the universe. It's this faint, ghostly whisper of warmth that fills every inch of space, and it is the absolute best evidence we have that our universe had a beginning. Now, these first stars, they were nothing like our sun. They were total monsters, violent giants, hundreds of times bigger, burning unbelievably hot and bright. They lived incredibly fast lives and died really young in the most spectacular explosions imaginable. And those explosions, they were the most important creative events in the early cosmos. So here's how they did it. Those giant stars were like cosmic factories. Deep in their cores, they smashed simple elements together to make heavier ones. But once they ran out of fuel, gravity would win, the core would collapse, and the whole thing would just detonate in a supernova. And in that explosion, all those newly made elements, we're talking carbon, oxygen, iron, even gold, got blasted out into space. They were basically giant cosmic recycling plants, seeding the universe with all the ingredients needed for the next generation of stars, planets, and, well, us. Okay, so the universe is now full of the raw materials for something more complex. This dust stardust, this ancient debris from long-dead stars, is about to come together and build our home. Let's see how that happened. Let's jump ahead to about 4.6 billion years ago, right here in our quiet little corner of the Milky Way galaxy. A huge cloud of all that gas and dust started to collapse under its own weight. At the center, it got so hot and so dense that nuclear fusion kicked in, and a brand new star was born. That was our sun. All the leftover stuff flattened out into this huge spinning disk around it, and that was the birthplace of the planets. So, why do we have such different kinds of planets in our solar system? Well, it's pretty much all about real estate. Close to the hot sun, only the heavy stuff like rock and metal could stick around. That's how we got the small, dense inner planets. But way out in the colder parts of the system, it was chilly enough for lighter materials like gas and ice to clump together, forming those massive gas giants. And Earth's birth was anything but gentle. It started as a red-hot ball of molten rock, just constantly getting smashed by asteroids and comets. Then came the single biggest event in our planet's history. Another protoplanet, about the size of Mars, slammed right into us. The impact was so huge, it blew a massive chunk of Earth into space, and that debris eventually came together to form our moon. It was only after all that chaos that Earth could finally cool down and the first oceans could form. So we have a planet. We have water. Now for what might be the biggest mystery of them all, the first spark of life. This is one of the deepest questions in science. I mean, think about it. You've got a sterile, rocky world, and somehow simple chemistry becomes complex biology. How in the world does non-living stuff manage to organize itself into something that is alive?
Now, we don't have the final answer just yet, but there are a couple of big ideas. One is that life got started in a warm little pond on the surface, with energy from sunlight and lightning cooking up a primordial soup of organic molecules. The other idea is that it started in total darkness at the bottom of the ocean, powered by the incredible chemical energy blasting out of deep-sea hydrothermal vents. The jury's still out.
But no matter where it happened, the first step was probably something super humble. Just a tiny bubble, a little fatty membrane, that happened to trap some molecules inside that could make copies of themselves. And the moment you have replication that isn't perfect, copying with a few mistakes here and there, you get natural selection. The engine of evolution had just sputtered to life.
For more than 1 billion years, life was just simple, single-celled stuff. But then came what might be the single greatest invention in life's history: photosynthesis. Some bacteria figured out how to use sunlight for energy. The thing is, their waste product was oxygen. And this waste was actually toxic to almost everything alive at the time, but it completely terraformed our planet, filling the atmosphere with oxygen and paving the way for bigger, more complex life, like us. So with a brand new oxygen-rich atmosphere, the stage was set for a massive change in the story of life. Things were about to get a lot bigger and a whole lot weirder.
And boy, did things explode. Around 541 million years ago, in what we call the Cambrian explosion, life went from pretty simple to unbelievably complex in what was, geologically speaking, the blink of an eye. All of a sudden, the oceans were just teeming with creatures that had shells and legs and eyes and skeletons. Pretty much every major animal design that exists today got its start in that incredible burst of evolutionary creativity.
Life eventually crawled out of the oceans and onto land. First plants, then insects, and then the giant reptiles. This kicked off the age of the dinosaurs, and they ruled this planet for an incredible 115 million years. It must have seemed like their reign would never end. Until 66 million years ago, a 6-mile-wide rock from outer space showed up. The impact was just unimaginable. It caused a global firestorm, massive tsunamis, and plunged the world into darkness for years. The result was devastating. 100% of the non-avian dinosaurs gone. And not just them. 3/4 of all species on Earth were wiped out. Life on this planet was pushed right to the edge. It was basically a global reset button. But here's the wild twist in our story. The absolute worst day in the history of the dinosaurs was the best thing that ever happened to our distant ancestors. You see, with all the giants gone, the small furry mammals that had been hiding in the shadows finally got their chance. The dinosaurs' extinction opened the door for us. And this is where that whole 13.8 billion year story comes right back home. The great astronomer Carl Sagan really put it best. And he wasn't just being poetic. This is a literal scientific fact that connects every single one of us to the very beginning of everything.
I mean, just stop and think about this for a second. The iron in your blood that carries oxygen through your body, forged in the heart of an exploding star. The calcium that makes your bones strong, made in a star. The carbon that forms the backbone of life itself, you guessed it, cooked up inside a star, billions of years ago and countless light years away. You are not just living in the universe. You are the universe. You are, quite literally, walking, talking stardust.
So, here we are. The product of 13.8 billion years of cosmic evolution, all the way from the Big Bang, to the creation of elements and stars, to the formation of our little planet, to that first spark of life. This whole incredible cosmic process has resulted in us, beings who can actually look back up at the stars and wonder how it all began. In a very real way, we are the universe, having become aware of itself. We are the cosmos's way of knowing its own story.